हाँ तो फ्रेंड्स, ये है क्वेश्चन नंबर 26 जो कि आया था सिविल सर्विसेज मेंस एग्जामिनेशन में 2016 में। और ये आया था 20 नंबर के लिए। तो ये एक थ्योरेटिकल क्वेश्चन है जिसमें कि हमको ये जो एक्सप्रेशन दिया गया है वो हमको प्रूव करना है इसके अंदर। तो पहले तो इसको देख लेते हैं कि क्वेश्चन में दिया क्या गया है सबसे पहले। तो इसमें दिया गया है सिलेंड्रिकल रॉड ऑफ लेंथ एल इंसुलेटेड ऑन इट्स लेटरल सर्फेसेज इज इनिशियली इन कॉन्टैक्ट एट वन एंड विद अ वॉल एट टेम्परेचर T1 and at the other end with a wall with a lower temperature T2. The temperature within the rod initially varies linearly with position x according to Tx is equals to T1 minus T2 divided by L into x। तो ये एक एक्सप्रेशन दिया गया है। एक ये लीनियर जो लाइन होती है उसका एक्सप्रेशन है ये। द रॉड इज इंसुलेटेड ऑन द एंड्स एंड इवेंचुअली कम्स टू अ फाइनल इक्विलिब्रियम स्टेट where the temperature is Tf. Evaluate Tf in terms of T1 and T2 and show that the amount of entropy generated is, that is S generated is equals to mc 1 plus ln Tf. So it is a very big expression, so no need to read this, you can read in yourself. Where C is the specific heat of the rod. हाँ तो फिर सबसे पहले जो एक्सप्रेशन हमको दिया गया है उसको ही शुरुआत करते हैं कि किस तरह से वो रिप्रेजेंट हुआ होगा। तो ये जो एक्सप्रेशन दे रखा है ये इक्वेशन ऑफ लाइन का है। तो इसके अंदर जो स्लोप है वो T1 - T2/L दे रखी है। तो T1 और T2 के बीच में जो लाइन है वो इस तरीके से रिप्रेजेंट की जाएगी। अब इसका एक स्कीमेटिक डायग्राम भी बना लेते हैं क्योंकि ये वॉल के बीच में दे रखा है। तो एक वॉल है जो कि है T1 टेम्परेचर पे और एक जो वॉल है वो है T2 टेम्परेचर पे जिसकी लेंथ है L। तो ये जो रॉड है उसका एक छोटा सा एलिमेंट लिया हमने dx। सो वी हैव टेकन अ स्मॉल एलिमेंट dx ऑफ दिस होल रॉड एंड इट्स एरिया इज a and as given in the question T1 greater than T2. So I have written here that if we take a small strip in the rod and calculate its change in internal energy, so this is du, not dw, it is du. So du is equals to dm multiplied by c into Tf, that is final temperature, minus T, that is the initial temperature that is given. So dm is equals to density multiplied by area into dx. So rho a dx multiplied by c into Tf minus T. So we get this expression of du, that is the change in the internal energy. Now if we integrate this formula or the expression for the whole length 0 to L, then we can get the change in internal energy for the whole rod. So if we integrate this, we get this delta U for whole rod as rho A L multiplied by C into Tf minus T1 plus T1 minus T2 divided by 2. So this comes out to be mc into Tf minus T1 plus T2 divided by 2. And as we know that rho Al is equals to m, so here we substitute, instead of rho L we substitute here m. Now according to the first law of thermodynamics, we know that the change in internal energy is equals to the heat supplied or the heat minus the work, that is work done by the system or done on the system. And we know that here it is a closed system and no heat transfer takes place and the work is also zero. So the change in internal energy for this system becomes a zero. And this thing we have calculated that the change in internal energy is a zero for this system. So in this question we have to calculate what is the entropy generated. So we know that the entropy generated is given by integration of 0 to L the small change in the entropy, that is the ds. So here again we use the formula of the entropy, that is mcp ln T2 by T1, that is integration of dq by T, and dq is equals to mcp dt. Putting here the value of dq and integrating, we get the integration of mcp dt divided by T. So here we get mcp ln Tf by T. So this is actually not total change, but it is the ds, that is the small change in the entropy. And now we have to calculate this small change of entropy over whole of this length. So we calculate by integrating this expression, and the entropy that is generated is given by this. And we also know that the temperature of this rod is linearly dependent upon the length L. So while in the expression of entropy generation as gen, we have to replace the value of T from this expression. So if we replace the value of T here, then there is the expression, it is given in the variable as dx, not in a variable of t. So we have to change the variable also. So here we can change dt comes out to be minus of t1 minus t2 divided by l into dx. So in place of dx we can put minus l divided by t1 minus t2 into dt. And if we put the value of dx in the expression there, and we integrate this ln t dx 0 to l, we get this big expression. And then if we substitute this big expression in the expression for S gen, this is the expression of S gen, that is the entropy generated over whole length L, we can get the expression that is demanded in the question. So this is the way we solve the question. It might look a very big question, but if we solve systematically, then we can easily solve the question. So this was the solution for this question. Thanks for watching. See you next time.